Alright, ready for acid-base titrations. Now, a couple of ideas that we're looking at here with titrations is, first off, the idea with titration is we're trying to find out the concentration of an unknown solution using the concentration of a known solution. Usually we're going to go till we reach what's called the equivalence point, which is a point where the number of moles of acid are going to be equal to that of the base. Also, in case you're doing anything with something that's not acid-base, it will still be the point at which you have equal amounts, or you precipitated out all the ions of what you're looking for. Now, in the case of what we're looking at here, we're going to look at a couple of examples and work through them based on formula and based on the concentrations and volumes that are given to us. Now, first example we want to look at is it says it takes 83 milliliters of a 0.45 molar sodium hydroxide solution to neutralize 235 milliliters of a hydrochloric acid solution. What's the concentration of, that's supposed to be of, sorry, the hydrochloric acid solution? Well, let's take a look at the formula that we're going to use here. We're actually going to use what's called MAVA. Oops, sorry. Take a step back. The molarity of our acid times the volume of our acid over the number of moles of our acid equals the molarity of our base, volume of our base, over number of moles of our base. Now, for a lot of what we're going to do here, it'll usually be a one-to-one relationship, but just in case it's not, we have to be prepared to actually solve based on that. Now, let's plug in the values that we have. We have our molarity of our base given to us, so we have 83 milliliters times 0.45 molar solution equals 235 milliliters, and we do not know our molarity. That's what we're trying to figure out. So in order to solve this, let's look at our relationship to see if we need to do any other adjustments. So it's HCl plus sodium hydroxide yields sodium chloride plus water. So we're actually already balanced here, so don't have to worry about the moles part. But let's get started here. So I'm going to end up dividing both sides by 235, so I can get molarity of our acid by itself. So 235, 235, that'll cancel, and we get M equals this agglomeration here. So taking it, plugging it into our calculator, we're going to end up getting 0.159 molarity. So we have a very, very weak molarity compared to our molarity of our base. As we can see here, the molarity being 0.159 versus the 0.45 molar solution. Now, I'm going to take this and now look at another example where we can actually see this a little bit more clearly. So it takes 38 milliliters of 0.75 molar solution of sodium hydroxide to neutralize 155 milliliters of a sulfuric acid solution. What's the concentration of the sulfuric acid solution? So let's look at our equation again. We have NaOH plus sulfuric acid, which is H2SO4, yields sodium sulfate plus water. Now, taking a look at this relationship, I actually don't end up with a one-to-one relationship. I end up with two-to-one relationship. So that's where the moles part is going to come into play. But I can go ahead and start off my calculation just as I normally would. So 38 milliliters of my base times the molarity is 0.75 equals, now and all this is for my base. I just have it written backwards, but it still works out the same. 155 milliliters of my acid, and I'm trying to find out the molarity. I'll just write this at the top. So, in order to get my molarity by itself, I divide both sides by 155 milliliters. I was going to cancel this here. And I'm going to get M equals whatever this volume is, well, which in this case it ends up coming out to 0.184. Now, the reason why I wanted to go back here, you notice that we had a 2-to-1 relationship. So that means that actually I'm going to end up needing to divide this molarity in half, because it takes 2 moles of the sodium hydroxide for every 1 of the sulfuric acid. So dividing this by the number of moles we had, which is 2, and we're going to get the actual molarity, and I'll write it normally for me, is going to be 0.092 molar. This is how we'll be able to use our balanced equation to check our work in terms of our neutralization reactions. Now, take a few moments, look at the examples I gave you on the worksheet, work through them. You realize that for the most part these are actually very quick problems, and you'll be able to run through them without too much of an issue. Have a good evening, and see you in class.